Hello and welcome to the walking talking topic on quadratics, question number 3 with me, Mr. Barton. Right, we're in extreme quadratics mode now. We've got all sorts going on this page, so let's see if we can get to the bottom of it. Express x squared minus 16x plus 66 in the form x plus a all squared plus b. Now you've got to spot that if it says that, that is classic completing the square. And a lot of people can do completing the square but don't spot it because they don't have a clue what's going on with this. But that means do completing the square. Okay? So how do we do completing the square? Well, the way I do it is this. If it's x squared minus 16x, I know straight away that I'm going to have something like that. X minus 8 squared. This number here is always half the number of x's, and you'll see why in a second. So once I've got that established, I then, somewhere else on the page, I actually work out what x minus 8 all squared is. So x minus 8 all squared is x minus 8 times x minus 8, and then I multiply out those brackets. X times x squared, x times minus 8, minus 8x, minus 8 times x, minus 8x, and finally minus 8 times minus 8 is positive 64. Be careful with that, positive 64. Let's tidy that up. X squared minus 8x is minus 16x plus me 64. Now that is what x minus 8 all squared looks like. It gives me x squared minus 16x plus 64. Look what I need. I need x squared. Well, I've got that. Got me x squared. I need minus 16x. Yep, got that. And that's why I need half the value, because when I expand it, when I multiply my brackets, it always works out to give me minus 16x from that minus 8x and minus 8x. But I need plus 66. I've got plus 64. That's going to give me plus 64. I need plus 66, so I'm going to need 2 extra. And that is the easiest way to complete the square. Next bit. Prove that, flipping heck, and that's a minus sign just in case it hasn't come out on yours. Prove that this flipping horrendous thing on the left is equal to 19 minus 6x all over 12. Now, the easiest way to do these proof questions is to deal with the most complicated side. And if this right-hand side is over 12, let's see if I can get my left-hand side over 12 and just treat it as a normal fractions question. So I want that first bit over 12 minus I want this second bit over 12 plus I want this last bit over 12. Okay, if I've got 2x plus 3 and at the moment it's divided by 4 and I want it to be divided by 12, I've made my denominator 3 times bigger to get from 4 to 12. So I've got to make my numerator 3 times bigger. So instead of having 2x, I'm going to have 6x, and instead of having plus 3, I'm going to have plus 9. Okay? What about this second fraction? I've gone from a denominator of 3 to a denominator of 12. So I've gone 4 times bigger. So I'm going to have to make my numerator 4 times bigger. So I'm going to have 12x minus 8 on the top instead of 3x minus 2. And then finally this one, I've got 1 over 6. I've made the denominator twice as big, so I've got to make my numerator twice as big. And now, even though this is algebra, the rules of fractions are the same. If you've got a common denominator, you can just combine those together over a single denominator. But just be careful. You've got 6x minus 12x. 6x minus 12x. That's going to give me minus 6x's. This is the bit you've got to be careful of. You've got 9 minus 8. So that's 9 minus 8. Add on me 2. What's that? 9 minus me 8, well that's going to be the same as 9 plus 8, plus me 2, 9 plus 8, 17, plus me 2 is plus 19. And lo and behold, look what we've got there. Minus 6x plus 19 over 12, that is the same as 19 minus 6x over 12. So you've proved it. And it all comes down to making common denominators. Okay? Next bit. Simplify this fraction. I'm just going to write this out because I know the font's a little bit small here. Over 10x plus 35. Now, if you ever get something like this, it's an algebraic fraction, it's always going to require you to factorise. Factorise the top, factorise the bottom, and see where you're at the end of that. Now, the bottom is significantly easier to factorise than the top, so let's deal with that first. 10x plus 35. Assume it's a single bracket. Is there anything common that we can take out of 10x and 35? Well, yeah, I think a factor of 5 goes in there. So 5 lots of 2x and 5 lots of 7 are 35. Now, a little trick here is that if you've got a factor on the bottom and it's asked you to simplify it, the chances are that's going to be a factor on the top as well. So I'd imagine this 2x plus 7 is going to come into play. It's not a guarantee, but I'd imagine it would do. So look at this top, 2x squared plus 5x minus 7. Assume it's a single bracket. Is there anything common we can take out of those? No, there isn't. So it's got to be a double bracket job. Now, if it's got a 2x squared, it has to be a 2x and an x. Now, if you use my sneaky technique here, let's work on the assumption that it is going to be 2x plus 7. I'm not saying it is, but let's work on that assumption. What would make that the second bracket then? So if it's a positive 7 there, and it's got to multiply together to give a negative 7, that would have to be minus 1. Does that work? Let's expand it and check. 2x times x, 2x squared. 2x times minus 1 minus 2x. 7 times x is positive 7x. 7 times minus 1 is minus 7. 2x squared. Got it. Have I got a 5x? Minus 2x plus 7x. 5x. Perfect. 7 times minus 1 minus 7. So it's worked. So that has got to be 2x plus 7, and that has got to be x minus 1. So how do we simplify that? Well, we can now divide the numerator and the denominator by 2x plus 7. So I end up with x minus 1 on the top, and I've got me 5 on the bottom. So always look out for that. More often than not, that happens, that if you simplify your linear factor first, then one of those factors is going to appear on the top.